8. Demonstrating invalidity using the method of counterexamples. Earlier we discussed some of the basic ideas of logic, including the notions of validity and invalidity. In the present section, we attempt to get a better idea about these notions. We begin by making precise definitions concerning statement forms and argument forms. A substitution instance of an argument statement form is a concrete argument statement that is obtained from that form by substituting appropriate descriptive terms for the letters, in such a way that each occurrence of the same letter is replaced by the same term. A uniform substitution instance of an argument/statement form is a substitution instance with the additional property that distinct letters are replaced by distinct non-equivalent descriptive terms. In order to understand these definitions, let us look at a very simple argument form. Since it has just one premise, it is not a syllogistic argument form. F all x are y/some y are z. Now consider the following concrete arguments. 1. All cats are dogs/some cats are cows. 2. All cats are dogs/some dogs are cats. 3. All cats are dogs/some dogs are cows. These examples are not chosen because of their intrinsic interest, but merely to illustrate the concepts of substitution instance and uniform substitution instance. First of all, 1 is not a substitution instance of f, and so it is not a uniform substitution instance either. Why is this? In order for 1 to be a substitution instance to f, it is required that each occurrence of the same letter is replaced by the same term. This is not the case in 1. In the premise, y is replaced by dogs, but in the conclusion, y is replaced by cats. It is accordingly not a substitution instance. Next, 2 is a substitution instance of f, but it is not a uniform substitution instance. There is only one letter that appears twice or more in f, namely, y. In each occurrence, it is replaced by the same term, namely, dogs. Therefore, 2 is a substitution instance of f. On the other hand, 2 is not a uniform substitution instance since distinct letters, namely, x and z, are replaced by the same descriptive term, namely, cats. Finally, 3 is a uniform substitution instance and hence a substitution instance of f. Y is the only letter that is repeated. In each occurrence, it is replaced by the same term, namely, dogs. So 3 is a substitution instance of f. To see whether it is a uniform substitution instance, we check to see that the same descriptive term is not used to replace different letters. The only descriptive term that is repeated is dogs, and in each case, it replaces y. Thus, 3 is a uniform substitution instance. The following is an argument form followed by 3 concrete arguments, one of which is not a substitution instance, one of which is a non-uniform substitution instance, and one of which is a uniform substitution instance, in that order. F no x are y no y are z/no x are z. 1 no cats are dogs no cats are cows/no dogs are cows. 2 no cats are dogs no dogs are cats/no cats are cats. 3 no cats are dogs no dogs are cows/no cats are cows. Check to make sure you agree with this classification. Having defined uniform substitution instance, we now define the notion of having the same form. 2 argument statements have the same form if and only if they are both uniform substitution instances of the same argument statement form. For example, the following arguments have the same form, because they can both be obtained from the argument form that follows as uniform substitution instances. A 1 all Lutherans are Republicans. Some Lutherans are Democrats/some Republicans are Democrats. A 2 all cab drivers are maniacs. Some cab drivers are Democrats/some maniacs are Democrats. The form common to a 1 and a 2 is f all x are y some x are z/some y are z. As an example of 2 arguments that do not have the same form, consider arguments 2 and 3 above. They cannot be obtained from a common argument form by uniform substitution. Earlier, we gave 2 intuitive definitions of validity. Let us look at them again. An argument is valid if and only if it is impossible for the conclusion to be false while the premises are all true. To say that an argument is valid is to say that if the premises were true, then the conclusion would necessarily also be true. Although these definitions may give us a general idea concerning what valid means in logic, they are difficult to apply to specific instances. It would be nice if we had some methods that could be applied to specific arguments by which to decide whether they are valid or invalid. In the remainder of the present section, we examine a method for showing that an argument is invalid if it is indeed invalid, the method of counterexamples. Note, however, that this method cannot be used to prove that a valid argument is in fact valid. In order to understand the method of counterexamples, we begin with the following fundamental principle of logic. Fundamental principle of logic: whether an argument is valid or invalid is determined entirely by its form. In other words, validity is a function of form. This principle can be rendered somewhat more specific, as follows. Fundamental principle of logic rewritten: if an argument is valid, then every argument with the same form is also valid. If an argument is invalid, then every argument with the same form is also invalid. There is one more principle that we need to add before describing the method of counterexamples. Since the principle almost doesn't need to be stated, we call it the trivial principle, which is stated in two forms. The trivial principle: no argument with all true premises but a false conclusion is valid. If an argument has all true premises but has a false conclusion, then it is invalid. The trivial principle follows from the definition of validity given earlier. An argument is valid if and only if it is impossible for the conclusion to be false while the premises are all true. Now, if the premises are all true, and the conclusion is in fact false, then it is possible for the conclusion to be false while the premises are all true. Therefore, if the premises are all true, and the conclusion is in fact false, then the argument is not valid, that is, it is invalid. Now let's put all these ideas together. Consider the following concrete argument, and the corresponding argument form to its right. A. All cats are mammals. F. All X are Y. Some mammals are dogs. Some Y are Z. Some cats are dogs. Some X are Z. First, notice that whereas the premises of A are both true, the conclusion is false. Therefore, in virtue of the trivial principle, argument A is invalid. But if A is invalid, then in virtue of the fundamental principle written, every argument with the same form as A is also invalid. In other words, every argument with form F is invalid. For example, the following arguments are invalid. A. 2. All cats are mammals. Some mammals are pets. Some cats are pets. A. 3. All Lutherans are Protestants. Some Protestants are Democrats. Some Lutherans are Democrats. Notice that the premises are both true and the conclusion is true, in both arguments A 2 and A 3. Nevertheless, both these arguments are invalid. To say that A 2 or A 3 is invalid is to say that the truth of the premises does not guarantee the truth of the conclusion. The premises do not support the conclusion. For example, it is possible for the conclusion to be false even while the premises are both true. Can't we imagine a world in which all cats are mammals, some mammals are pets, but no cats are pets? Such a world could in fact be easily brought about by a dastardly dictator, who passed an edict prohibiting cats to be kept as pets. In this world, all cats are mammals. That hasn't changed. Some mammals are pets, for example, dogs, yet no cats are pets in virtue of the edict proclaimed by the dictator. Thus, in argument A 2, it is possible for the conclusion to be false while the premises are both true, which is to say that A 2 is invalid. In demonstrating that a particular argument is invalid, it may be difficult to imagine a world in which the premises are true but the conclusion is false. An easier method, which does not require one to imagine unusual worlds, is the method of counterexamples, which is based on the following definition and principle, each stated in two forms. A counterexample to an argument form is any substitution instance not necessarily uniform of that form having true premises but a false conclusion. B. A counterexample to a concrete argument A is any concrete argument that 1 has the same form as A. 2 has all true premises. 3 has a false conclusion. Principle of counterexamples. A. An argument form is invalid if it admits a counterexample. B. An argument form is valid only if it does not admit any counterexamples. The principle of counterexamples follows our earlier principles in the definition of the term counterexample. One might reason as follows: suppose argument A admits a counterexample. Then there is another argument A such that 1A has the same form as A, 2A has all true premises, and 3A has a false conclusion. Since A has all true premises but a false conclusion, A is invalid, in virtue of the trivial principle. But A and A have the same form, so in virtue of the fundamental principle, A is invalid also. According to the principle of counterexamples, one can demonstrate that an argument is invalid by showing that it admits a counterexample. As an example, consider the earlier arguments A 2 and A 3. These are both invalid. To see this, we merely look at the earlier argument A, and note that it is a counterexample to both A 2 and A 3. Specifically, A has the same form as A 2 and A 3, it has all true premises, and it has a false conclusion. Thus, the existence of A demonstrates that A 2 and A 3 are invalid. Let us consider two more examples. In each of the following, an invalid argument is given, and a counterexample is given to its right. A 4 no cats are dogs. C4 no men are women. No dogs are apes. No women are fathers. No cats are apes. No men are fathers. A 5 all humans are mammals. C5 all men are humans. No humans are reptiles. No men are mothers. No mammals are reptiles. No humans are mothers. In each case, the argument to the right has the same form as the argument to the left. It also has all true premises and a false conclusion. Thus, it demonstrates the invalidity of the argument to the left. In A 4, as well as in A 5, the premises are true, and so is the conclusion. Nevertheless, the conclusion does not follow from the premises, and so the argument is invalid. For example, if A4 were valid, then C4 would be valid also, since they have exactly the same form. But C4 is not valid, because it has a false conclusion and all true premises. So, C4 is not valid either. The same applies to A5 and C5. If all we know about an argument is whether its premises and conclusion are true or false, then usually we cannot say whether the argument is valid or invalid. In fact, there is only one case in which we can say when the premises are all true, and the conclusion is false, the argument is definitely invalid by the trivial principle. However, in all other cases, we cannot say one way or the other. We need additional information about the form of the argument. This is summarized in the following table. Premises conclusion valid or invalid? All true can't tell. Need more info all true false definitely invalid not all true can't tell. Need more info not all true false can't tell. Need more info